Hello everyone, Mr. John here with a ZIML Brain Potion today. We're going to be discussing a little bit about mathematical games, with the theme being Stop Copying Me, and we'll explain where that kind of name comes from in a little bit. But first of all, I want to talk first about what is a mathematical game. So we all know what games are, right? We may play video games, we might play board games, we might play card games, right? We might play sports, that's another type of game. Typically here in a math problem, or if we're talking about a subject called mathematical games, these are a defined set of rules, typically 2 players, right? You have a winning condition, maybe a losing condition, and there could be ties, of course, other things like that. Now, typically these games are fairly simple, and the winners are determined. What do we mean by that? Think of this more like a game like tic-tac-toe, right? Of course, when you were younger, you played tic-tac-toe, you would win some games, you would lose some games. As you got older, right, you probably stopped playing tic-tac-toe so much. Why is that? Well, unless the first player messes up, the first player should never lose. In fact, if the second player never messes up, the first player should never win, right? So the game is determined. If you play perfectly, if you play without making mistakes, you can decide who wins. So that's what a lot of these games are going to be like. So it's almost like a puzzle, right? You have a game, you then need to decide who wins. Of course, we mean if they're playing perfectly. So how do you play perfectly? What is the strategy? What is kind of, given a board setup, what's the move you should make to make sure you win or make sure you don't lose, different things like that. So our first game here is going to be fairly simple. A lot of you may have heard of this game. This is a very famous game in different forms. But the setup here is you have 2 piles of 7 stones. That's our example setup here. Each turn, a player can take as many stones as they want, but from only one of the piles, right? So I have kind of a black pile and a gray pile in this example. And you must take at least 1 stone each time. Otherwise, you'll have infinite times where nobody, right, wants to take a stone maybe or something like that. And whoever takes the last stone wins in this case. So just to be clear a little bit, it's not like one pile is for one player, the other pile is for another player, right? So maybe as player 1 here, represented in blue, they could take, say, 3 stones from the first pile. Remember, as many stones as they want, but at least 1, right? The second player then maybe takes 2 stones from the first pile, right? It's not like my pile, your pile. Maybe we go back, the first player takes 1 stone from the second pile, right? These things are kind of all allowed in this case, right? So those are kind of different moves. Those are different possibilities for this there. And we want to come up with a strategy for winning if you're one of the players there. Now, in fact, right, like we said, these games are determined. If you play well, you should always win. So here's where the name of today comes in. In fact, here the second player can always win by copying, or we're going to kind of call this in more advanced stuff, stealing whatever the first player does. So this is this idea of a strategy stealing argument. Now, how does this work? So going back to our kind of 2 players here. So suppose the first player takes 1 stone from the first pile. Then the second player copies them, right? Steals their same exact move. They remove 1 stone from the second pile. Now notice, after this move, and this will be the theme, both piles are the same at the end of the second player's move. So there was 7 and 7 to start with, now there's 6 and 6. And again, this can go between the piles, remember. So maybe in the next move, this first player takes 3 stones from the second pile, And then second player then can go back and take 3 stones from the first pile. So they're always going to copy, of course, on the other pile, but they're always copying whatever that first player does. Now, right, why do they win? Well, notice whenever that first player takes all the stones from one pile, right, you probably saw this immediately, right? Once one pile is empty, the other player can go in and empty the other pile, right? So this would be the example here of the second player taking all of those stones from the second pile then and winning in that case. So that's then their stealing, right? Once one pile is empty, right? Since the second player always copies the first player, it's not like the second player is ever emptying a pile. They only empty the second pile when the first player empties the first pile. And then that means that the second player wins, right? Because whoever takes the last, that final stone, is the winner at the end. So this is our general idea of this strategy stealing argument. So this brings us to kind of our first question. Of course, some stuff can be changed, and you might need to be careful with some extra strategies or some extra parts to these strategies as well. This game is an example of a pretty famous math game called Nim. We might revisit this game in further videos later on as well. This is the case, of course, with 2 piles, meaning there's 2 piles of stones. So this is 2 pile Nim in this case. In more generality, you could have 3 piles, 4 piles. That gets more complicated, and that's really where the fame of Nim comes from. But for our purposes, even 2 piles is a good first question here. So we looked at one example, 7 and 7, right? 7 stones in each pile. And so our first general question here for you guys to think about, we'll have some discussion in the comments below or on the ZIML site. I'll say about that at the end of the video. If you just in general have one pile with m stones, one pile with n stones, right? Of course, these are positive integers. Maybe they're the same, maybe they're different. In that general kind of case, can you describe a rule? Player 1 wins in this case, maybe never, right? Player 2 wins in this case. We already know there's some cases, or at least one case, player 2 wins, right? But just explain what happens in general in this game. Who wins and why? Okay. So, right, as a hint here a little bit, right, you can look at some examples, right, but then think about this strategy stealing work. When does this copying work as something that could help out there? So, second example here, we have a flower with 9 petals. Every turn, right, we have 2 players again, they either remove 1 or 2 petals. Right, so maybe let's use red and blue as our players this time. So the first turn, maybe I remove 1 petal up here. Maybe the second turn, right, the next player removes 2 petals right next to each other like that. Right, so these things have to be next to each other right there. It's not allowed as player 1. I can't come in and then remove these 2 petals next. That's not allowed because those petals aren't next to each other in the flower. We don't have to be building around, right? So maybe in the next move, the first player removes these 2 petals over here, right? And so now we've kind of split the flower into 2 pieces, which will come up in a second. But similar to the piles in Nim, whoever takes the last petal wins in this case. Now, it's an example, so we shouldn't be too surprised that this is another strategy stealing argument, but we have to do a little bit of work in this case. So what's the goal here? The goal is we want to kind of turn this into something that reminds us of 2 piles where we can copy each other. So here we have 9 petals, so our eventual goal is we want to divide this flower into 2 sides, right? So 2 separate pieces with 3 petals each. So how does this work? Well, if the first player removes a single petal, right, so they removed one petal, now we have 8 left. So if we want to divide this into 2 equal pieces, the second player can remove 2 petals opposite, and then that gives us our 3 and 3 here, right? So we have 3 petals on one side. Well, let me make this match the green, and then 3 petals on the other side. And now they copy, right? If the first player removes the middle petal on this side, they remove the middle petal on the other side, right? So we just kind of copy in the same exact way, always keeping the 2 sides now identical. And then because they're copying, they have to be the one to remove the final petal and therefore win. So what if the first player removes 2 petals, then the second player removes 1, right? So that's just kind of the same exact situation here with the colors reversed. So pretend first the blue removes 2, then the red removes 1, and then you go from there copying the other player as well. So these are kind of 2 simple examples of the strategy stealing, right? And so these can be helpful in a lot of cases. So as our kind of second question, this is actually a AMC 10 question from this year. So Bella and Jen play the following game on a closed interval 0n. So this is the real number line. So we have some number, at least 4, and then they're picking numbers on this number line that could be kind of short, could be longer, things like that. Bella picks a number, and then they alternate picking numbers, but every turn, each number has to be at least 1 away from the previous number, right? So it has to be more than 1 unit away from all the numbers chosen previously by either player. So think of it kind of as you pick a point, but then that kind of X's out, gets rid of a whole interval that is now not allowed. And the first person who is stuck, right, who cannot move at all, will win the game. So the question, again, we can discuss this below or on the ZIML site, is who wins the game, right? What's the strategy? How does that work in this case? So just to do kind of a quick little example, right? Not to even show who wins optimally or something here, but just to kind of make sure you're clear with kind of what the game means, right? We could look at kind of what happens here. So maybe say Bella picks the number here. So Bella goes first, and maybe Bella picks 1.5. Right, so then if Bella picks 1.5, that's really kind of getting rid of all of the numbers from 0.5 up to 2.5, right? So all of those kind of numbers are X'd out in this case. Right, so then next player, right, Jen here can take a move, right? So maybe Jen makes a move here at the number 5, right? So if Jen moves the number 5, then of course that kind of X's out all the numbers from 4 to 6. And then kind of alternates in this way, right? So you could kind of say here, okay, we're going back and forth then, and remember whoever takes the last move kind of is the winner. So if we just follow this through, I'm not going to show exact numbers here, right? But let's show a way that Bella loses. Bella could pick a number here, right? That kind of knocks out all of these numbers in the interval. And then that means Jen, right? Bella made kind of a mistake here. Jen can pick a number and X out all of the remaining ones there. And so in this scenario, then we have that Bella loses and thus Jen wins. So that's kind of our example of how this could work in this case. Looking at one final question, right? You, of course, have to decide, did Bella play the best she could, right? Is there better things she could have done? And think about other various n as well. As one challenge question here, I have one more challenge one here too, that'll let you guys think a little bit more about yourselves. You can, of course, ask some questions if you have them. But here n is a fixed positive integer. So we just start with a number. Nothing is written on the board. So two players take turns, write positive integers not exceeding n on the board. So they could write 1, 2, 3 up to the number n. The only rule is you're not allowed to write factors of numbers already written. So if somebody wrote 6 on the board, you couldn't write 1, 2, 3, or 6 again, right? We can't repeat the numbers on the board. We can't write numbers that are factors of the numbers already written. As with some of our games, like the previous one, the first player who cannot make a move loses. And we want to prove that the first player can always win using a strategy stealing argument. So this one's kind of a little bit of an interesting problem here. As a hint, you're not going to actually describe their strategy. So that's a little bit weird. You can prove they have a strategy that always wins, but you don't have to say exactly how that works. And my second hint here is to think about this game we described right now along with an alternate game. So suppose the alternate game was saying, right, okay, what happens if the first player writes down the number 1, right? That is possible, but how would the things change? How would the setup of the game change if they're not allowed to start with writing the number 1? And so that's kind of a good thing to think about in that case. Let us know if you have questions about this game, clarifications of it. But this one is much more challenging and will be good to think about, and we'll probably make a follow-up video explaining this one sometime in the future. So finally, in closing, right, you can discuss these problems in the comments below, or I'll also make a forum post on ziml.areteem.org for more discussion there, more questions there, right? That's kind of an easy place to discuss things. You can kind of type math equations there, so that's a little bit nicer than the YouTube comments, but feel free to ask questions below and stuff as well. And also, while you're there at ziml.areteem.org, there's a lot of great other free practice, right? Daily magic spells, some free problems there, monthly contests, and different kind of math contest archives, right? So this problem we saw earlier was an AMC 10B problem from this year. If you want to see the other AMC 10B problems from this year, those are there at the ZIML site as well. You can take a practice test of those questions too. So lots of great things there as well. So I hope to hear some discussion in the comments below, right? Please subscribe if you guys want to see some more videos of this, right? Let us know that you like this content so we can keep creating it. Otherwise, Mr. John saying goodbye for now, and I'll see everybody later. Goodbye.